This problem is asking us to find the derivative for each and every single term that's here. So we have 1 term, 2 terms, 3 terms, 4 terms, 5 terms, 6 terms, 7 terms, and 8 terms. First, we're going to start off with x. X is technically x to the 1, and by the power rule, we know that there's technically another 1 over here, so we would do 1 times 1, which equals 1, and we move this 1 over here. But we also know that x1 to the minus 1 would equal x to 0, and elevated, that would just be 0. So we would put g of x equals 1. And now we need to find the derivative of secant, which we know is going to be secant x tan x. And now we need to find what we already know is the derivative of x, but we would write it out as sec1. So we put secant 1 right over here, and now we move on to the rest of the terms. Cosine, we know the variable or the derivative for cosine is going to be negative sine, and then we just gotta keep these with it, those terms. And now we do the term for tan, and we know that the derivative is going to be secant squared. We got to keep the x to the 4th. And then we need to find the derivative for x to the 4th, which we know 4 times 1 is 4, so we move the 4 in front of the x. And then 4 minus 1, which equals 3, so it'd be 4x cubed. 4x cubed. And now we need to find this derivative for this one, and we see that it's an inverse sine, so we need to know the inverse sine of sine, which we know is going to be 1 over square root of 1 minus x squared. And then we got to remember to keep this along with it. So we're going to put 1 over x, and then we need to know the derivative for 1 over x. Which is going to be which is going to be 1 over x2, because 1 over x transformed is going to be x to the negative 1 minus 2 equals x negative 2, and then rewritten is going to be 1 over x to the 2. And this should be it for our first problem. Our second problem asks us to find the derivative as well. We're going to want to find the derivative of this, but it's going to stay the same because the derivative of anything exponent is going to be the same thing, just the derivative of exponent. But now we need to find the derivative for this, which is going to be ln times e to the negative 1. In other words, this could be written as just 1, because we need to do the natural log to get rid of e, so we can move this down. And now we're going to move on to our next term, the ln. Ln's derivative is going to be 1 over x, which in this case is going to be 1 over cotangent x. And we got to find the derivative for cotangent x, which we know is negative cosecant squared to the x. It's going to look like this. And then we need to find the derivative for these two terms. The derivative for log 2 is going to be 1 over ln 2, and then 5x. We have to account for the 5 of x. And then we need to find the derivative for 5 of x, which is just going to be 5. Because 5x to 0 is 5. And this should be it, unless you want to simplify it and go like this. Plus 1 over cotangent x secant 2x minus 1 over ln 2 5x times 5.